STM32CubeMX and then add board support BSP to that. So a little bit of background. What I wanted to do is I wanted to use the examples. So basically this firmware package here. Inside there's examples, and the example I was looking at is a LCD example, but it's only LCD. I wanted UART as well. Then there's different UART examples. Then I wanted to combine UART and LCD, but because they lay on different folder paths, all the paths is different for each project, so combining them looked like it's going to be difficult. So then I thought of using MX to create a project that both has support for UART and LCD. So let's do that. So the board I'm using is the STM32F429i Disco that has the LCD on. Okay, so in this search bar you can type F429. There's my board. Select the board and start project. Initialize with default peripherals, yes. Then it adds all the default hardware that's available on the board. Okay, system core, nothing to change. Let's focus on what we want. Connectivity, there's UART 1, so it is already enabled. Click on UART 1 and I go to GPIO. It's pin PA9 and PA10. That's the same pins they use on in the example. So this is fine. The only thing I'm going to change here is to enable global interrupts because I want to use interrupts. And that's it for UART. Multimedia, you'll see LTDC is enabled. That's the low-level driver hardware or HAL driver for the display for LCD. Middleware. Here I just want to set turn off FreeRTOS. I don't want to use real-time operating system. That's it. And then the project manager, I'm just going to use it, call it combine. This is the project location. I'm just going to select and it will use this firmware package, the same one I downloaded already. If you haven't got it, first time you use MX, it will ask you to download it, and if this is set to the latest, it will keep downloading the latest, which might be a problem later on, because what we're going to do now is MX uses this to build a project based on all the HAL and middleware stuff that's available in here. And what we're going to do now manually, we're going to copy from this in Explorer all the files and folders we need for board support. The thing is, CubeMX just generates a whole hardware abstraction layer for you. It doesn't create the board support. So if you're just working on the HAL layers, it's going to be more work to write nice drivers for the LCD. If you look in the examples, you'll see a lot of the functions is called BSP, something, let's say BSP draw a rectangle, BSP draw a circle or something. So it's easy to draw a rectangle, it's easy to draw a circle and do some nice things on the LCD with the board support. But using the HAL layer, that's not possible. So I don't want to do it the hard way. So yeah, I want the board support. Anyway, so just keep in mind, if you leave this on later, it will update later ones, which might cause problems. Generate code. This is not that fast. Okay, I don't want to open it now, I can just close it. So let's go to the folder it created that, and there's my project, there's combined. So this is the project that CubeMX just generated. If you open it, there it is. So any project that you see an IOC file means it is MX compatible. If I double click on this IOC, it will open up again in MX, and then you can change some configuration and generate it again, and it will override some of the files. If I double click on .project, it will open in Cube IDE, where you can continue with your code and add all your things. So the thing about MX is it just generate the initialization, doesn't create any real functions running. It's just initialization functions for all your peripherals, things that you selected. Okay, so on the left hand side I have my firmware package that's been downloaded, the same firmware package that CubeMX used to generate this code override. So inside here, let me go to the two projects that examples that I referred to. So if we go down to my board, applications, display, LTDC paint. This is the one project I was looking at to use on the LCD, but it's only an LCD project. And you see there's no ios.ioc file, so this project is not MX compatible, so you can't open it in MX. You can only click on .project and open it in the IDE. I wanted to use this project and combine it with, let's go back, examples, UART. This project is the UART example. Again, it's not a MX project. You can open it in IDE, and it also works, but it's only UART, no LCD. So to combine them was a bit tricky. So anyway, now we have a whole layer project called Combine, and I want to add port support in this project. So what I'm going to do is go back to my, okay, so in this project over here, the combined one that we created now, if you click on drivers, you'll see there's two folders on the boards, on the firmware package. On the drivers, you'll see there's a board support folder. Copy that over here in your project. Then open board support. We don't want to use all of this. You can delete components and leave your board that we're going to use, this one. So delete all the rest. Inside components, I'm not going to delete all the things we don't need, but basically we're just going to need this guy over here and this guy over here and the common directory. So you can, if you want, to delete the rest. This is the chips, the ICs used on the LCD. Not sure what this one is. I think it's also an IC used on the LCD. But I'm just going to leave all of them in there. Sorry, I don't want to go back there. So let's go to the next one, STM. components, add everything, STM discovery. For files. Anyway, and here also again you will only need TS, this is your touchscreen. STRAM, I think we're going to use the LCD, going to use the IO, going to use gyroscope, no, EEPROM, no, and this one, yes, but I'll just leave it in there. Right, the next thing you need, if you go back to the project, this space, and the firmware package here is utilities. Copy utilities, paste it over here. This is just some nice things like the fonts, so we only use the fonts. You can confirm this by opening the LCD, that example project, and you will see what they use. That is how I figured it out. So in fonts, I just delete the HTML stuff again. So this fonts is just default fonts they created, size 8 to 24. You can create more if you want. Just easy for the LCD to select them. Okay. That. Then, what else was there? Let's go back to projects, combine. So I have the utilities and I added my board support over there. Okay. Then let's open this project. Projects, combine. Now I'm going to click on dot project to open it in the IDE. Okay. Okay, there it is. Successfully importing the project, combine into the workspace. So this is, I already opened this LTDC example from the firmware package because we will use some things from there. So if you open this project, combine, and you open drivers, and you'll see there's your BSP and your components that we just added, as well as the utilities and the fonts. Alright, so that looks fine. Then you need to add this to your search or your include paths. Project properties, then you go to C++ general, add paths and symbols, and you need to do it both for debug and for your release version. Currently it's set to debug. Click drop down release, but let's do first for debug. You add file system. Now we go to the project. Let's make sure we're under project, combine. We go to drivers, BSP, and we select the components. And select that. Say okay, there's your extra search path. Another one for the STM discovery board. Select folder, okay. Alright, there's those two, and then we do the same for release. Add add components. Okay, apply and apply and close. Right. Then we're still going to get errors. Let's just run the release. Build the release. Yo, this computer is slow. Remember, this code that we're building is still the MX project. That is only the initialization functions. We haven't added any board support functionality in the code yet, even though the folders are there. Okay, so build fine, let's debug. The version I'm using for CubeMX is 2.0.0 and MX, I'm not sure, 1.16 I think. Okay, so it works. Now if we open our continuous main, core source main, then when we go down, see there is all the MX initializations it calls, and in the main, well, there's the headers and there's the initializations. So just initialize it and that's it. There's nothing happening. Right, if we go to our example for the LCD that I used or wanted to use, and we look at its main, you will see that from here is the LCD initialization. You see there's a BSP in front of all this, meaning board support. So this is the functions that we want to use. Why? Because if you go, so this is basically just the initialization of the LCD up to the touchscreen calibration. But if you go to this function here where it says draw menu, so if you run this, it will be a paint, looks like a paint, you know, the paint on your PC. You can draw with different colors. It looks like a small paint interface on the LCD. If I go here, then you'll see only board supports as well. But the nice thing is there's BSP LCD draw rectangle, fill circles, display strings, and this is what makes it nice and easy to draw on the LCD. And this is the functionality we want to add. If you just build a CubeMX project, you start using these functions, it won't build. But now we included all the dependencies, so now we can use them. Okay, so let's start and initialize the LCD. This is just LED, so let's ignore that. So from here on, I'm going to copy until the calibration over there. Copy that, and we're going to put it in our main of the other function. So for I'm gonna take out all of this now because the board support initialize the LCD already. So for this project, we're just going to use UART and the LCD. But because the board support initializes all of this, you don't want to use the MX initialization now. You'll see if you go into the code, they use basically the same hardware abstraction layers at the end of the time, but it's going to mess things up if both try to initialize it. Okay, so board support, initialize, select the layers, layers, and up to calibration. Let's just run or compile that project. It complains about some stuff. Let's click on the first thing. Complains about this frame buffer. So what I do now is go back to my example, and I go to the part where I hold down control, click on it, and it jumps to main header. So these defines need, and basically this headers here as well. I'm going to copy that, and it will be this includes as well. Let's copy only this for now, and let's go to this. This one's header file. I'm just going to drop it here, and I would also need these ones. Copy, paste. There. Okay, let's try again. Save, and let's clean and bolt. Okay, some more errors. Touchscreen calibration. Where is that? Only find reference to touchscreen calibration. Oh, okay. That is, let's go to our Explorer, and then we go to, now we need to go to the example that I used. Of course, we use the board support functions from the example. There's a touchscreen C file that it uses for access projects. Examples, not UART. Sorry, I'm at applications, display, paint, and then source, this TS calibration. Copy, and now we go to our project, and we include it in our source location. Now this TS doesn't have an include file, so that's it. Let's go back to our IDE. So now if you look at this, there it comes. You see the TS calibration. Let's build it. Okay, built. But it only initialized until calibration, so still it won't do much. Let's add the draw function, or the draw function. So I'm back in the example now. Oh, go on, then you'll see there's a draw menu. Let's copy that. So basically this is your paint user interface that it draws with all the pencils, the colors, and the screen, so small screen where you can draw and stuff like that. So let's copy that and paste it in our project just before the main. Function. Everything is just dropped in main now. You can later on move it to nice functions or files that work for you. Here. See, there's all your board supports, and then copy that prototype on top. Trying to draw a menu now. Color 2. Now this is a file that they use, so it's going to complain about this color 2 and the save. That's not included. Let's go back to our Explorer. You don't need it, it's just to show you all the nice, or how the screen looks. So in the example, there you see the save and the color. Let's copy those and paste it in our header, so it includes. Okay, and then we include it in our H, and okay, it's built. Okay, now it bolts. So let me connect the LCD and do the release. Okay, and then we run it. Release. It's the release. Release. Apply. Go. Okay, download it. But now you see the LCD screen looks messed up. Can't see it nicely, but looks like a broken screen or something. Anyways, that is because the clock configuration done in MX is not the same as done in the example. So we're going to use the example's clock configuration. Go to main, you go to system clock config, and I'm just going to copy all this. Let's copy the comments as well, then it lines up. Copy that, and I'm going to paste it. There. Save it and build it. Oh, sorry, we built and I forgot to run. Let's run it. Okay, the first thing it asks is calibrate. Can't clearly see, but let's get over this calibration thing. And there's the paint. Colors is your crayons, the thickness of your crayon, and the area where you can draw. Obviously this won't work for drawing now. I didn't include the touch, get touch position part, but just to show the LCD works quite well. There you can see the pencils. Okay, now let's add UART. I don't have logic analyzers and things over here to test to show you, but it does work. And so UART is not going to use board support. Board support functionality is only for hardware added onto the board outside of the MCU. So we don't need board support for the UART. UART will only use the whole layer, which is already generated. But I'm going to take the code from the example, since all the initializing and things has been done over there. So let us open that project. Application project, repository, examples, UART. I want this one, and I'm just going to click on project. Okay, successfully imported. There it is at the bottom. So if we go to this, just close all this. Samples, users, main. Okay. then this part is initializing the UART. You can use the MX initialization as well. The MX initialization will basically call this. I think it's safer to use the MX initialize. I did use this, it does work. The only thing you need to change is your UART handle. Because here they use UART handle. You see UART handle, there's your type def. But in this MX created code, see they created the handle here and it's called HUR. It's a different handle. But you can copy that code and just change the handle to this. So if you go into, let's enable the UART, this one. The MX initialize. If I go in here, you see exactly the same as in the example. Let's go to the example. See this part? Exactly the same as this part. So the only thing that you now can change is your baud rate. So this, you see there's UART 1 and here it calls UART X, but UART X is defined here, which is UART 1, so it's the same UART. So let's use MX, then the handle is right, because later on in the code, in this UART init, they're going to check for the UART handle. Is it here? No. When you transmit, I think when you transmit. So anyways, that's your UART initialization. You can set the baud rate, change the baud rate over there. Whatever you add your settings in MX will be over here. But it's your normal word length of 8, stop bits 1, parity none, it's transmit and receive. UART hardware control is none, oversampling 16. So yeah, you can just go ahead and change your baud rate, whatever you want there. This will only initialize it. And then to transmit, I'm going to take the transmit function from this code, the example. So basically we've done that part now. I'm just going to add this define here, because I think, no, this is only for the example. This is not needed in the MX code. They're not going to look for the transmitter board. In the example, they look for that. Okay, so you can copy this RX buffer for when you receive and the transmit buffer, just to use as an example. So basically you will send this UART to board commit IT. You will send it 3 times. Copy that. And paste it on top. Just going to drop it here. Okay, and here's our transmit function. So basically this, sorry, that's the receive, there's the transmit. But you must just change your handle when we copy this. So we'll use that buffer that we copied now on top. Handle, so let's copy just that. Just after drawing the menu. Boom. And let's change the handle to the handle we're using here. This handle here, so you can get it right on top as well. Here's your handle. Copy and paste it there. Paste. Right. Let's see if this code builds. Build. Example and px buffer size. So all this these three we need. We're going to just sort of paste it in the main header. Very messy, but just to get it working. You can later on move it to other source C files. Sorry, this is the example. This is our code. Copy it from main, from heading, yeah, header. Let's place it there. Okay. Okay. Well, I have no way to show you that the UART works, but you can run it. If you connect the terminal or your screen, there's the LCD running, and of course past the draw function, it already sent the UART command on those pins. Alright, so I hope this helps, and yeah, that can get anyone going on the LCD and the UART using board support.